Screen is visible?
Yes, sir. Visible, sir.
Okay, okay. So all the formula I have summarized. If you remember this formula, any type of state space test question we can solve with this formula. So these are the state equations. Okay. First two equations are the state equations. So where x dot is equal to ax plus b, where x are the state variable and y is the input to the system. So this kind of matrix will be given x dot is equal to x plus bu and y is equal to cx plus du. So we can calculate the transfer function by using this formula. Okay. So that is C into Si minus A inverse B plus D. Here I is the identity matrix. Okay. And so sometime what mistakes we are doing in question, D value will be given, but sometime by mistake we'll avoid the D and we use only this one. So that will result in a wrong answer. Okay. So this we should remember the transfer function equation. Similarly, the state transition matrix. So this term C into Si minus A inverse B plus D, this is called as state transition matrix. So inverse Laplace of this Si minus A inverse, which is phi of t, this is called as state transition matrix. Some of the property of the state transition matrix are here. These are the state transition matrix properties. So first one is phi of 0 is equal to I. Okay. So if you put t is equal to 0 in this phi of t, that will give a identity matrix. Similarly, phi to the power k t, it will be phi bracket kt. Okay. And similarly, if k will be minus 1, so phi inverse of t will be phi minus t. And the fourth one is phi t1 plus t2, that will be phi t1 into phi t2. So this all we should remember. Okay. Now this is a very important formula. So many competitive examination, this question comes based on this formula only. So x of t is equal to this zero input response and zero state response. These two summations are there. So first one is phi t x zero, okay, and second one is L inverse phi s into b into ua. Okay. So I will solve some question based on these equations also. And how we can calculate the output? So output will be C into xt. So first we will calculate x of t by using this equation. Then y of t will be equal to C into xt. Okay. Now the third term is to checking the controllability and observability of the given state system. Okay. So this controllable matrix will write and observable matrix will write. So that is B A B A square B. This is controllable matrix and this is observable matrix. So this is C C A C A square. If this will not be equal to 0, then it will be controllable, and if it will be equal to 0, determinant of this matrix will be equal to 0, then that will be not controllable. Okay. Similarly, for this one, if not equal to 0, that will be observable, and if it will be equal to 0, that will be not observable. Okay. So I think all of you have covered already this formula in the NPTEL lectures. So, okay, this is also very important term, controllable canonical form. Okay. So how I am writing here, I will explain. This is a equation given. So y to the power 4 dot is given here. 4 dot means d square 4 by dt square. Okay. Here 3 dot is given. Here 2 dot is given. Here nothing is given. Okay. So what am I doing? I am assuming y is equal to x1. Okay. Then x1 dot is equal to x2. Here some term will be missing, that is 0 y dot. Okay. So x1 dot is equal to x2. Similarly, I am assuming x2 dot is equal to x3 and x3 dot is equal to x4. Okay. So now this term will be x4 dot. So x4 dot will be equal to minus 8x1, okay, minus 0x2, minus 4x3, minus 2x4, plus 9u. Okay. So like this, we can derive the ABCD matrix from this equation. Okay. Is it clear how I have written this, or should I explain once more? See, any differential equation is given. Okay, this is a differential equation. So y to the power 4 dot plus 2y3 dot, okay, plus 4y double dot plus 0y dot. Nothing is given means that will be 0y dot plus 8y is equal to 9u. So I am assuming this y is equal to x1. Step 1 is this one. So x1, so that will be y is equal to x1. Okay. So x1 dot will be equal to x2. Okay. So this is x1 dot. X1 dot means y to the power dot. Okay. So this is x1 dot. X1 dot is equal to x2. Similarly, x2 dot will be x3 and x3 dot will be x4. And this is our x4 dot. This last term is x4 dot. So x4 dot is equal to this. I am putting in the right hand side. So this is minus 8x1. Minus 8x1 minus 0x2. Okay. Minus 4x3 and here minus 2x4 plus 9u. Is it clear this equation?
Yes, sir.
Okay. So from this we can write this ABCD matrix x dot is equal to AX plus BU. Okay. So A will be like this. See 0, 1, 0, 0, 0, 0. See x2 was there. Here x3 is there. x2 dot is equal to 0, 0, 1, 0. Similarly x3 dot is equal to 0, 0, 0 and 1. And x4 dot will be equal to minus 8, 0, minus 4, minus 2. So this is A matrix, B matrix, and this is C matrix. So this form is canonical form, controllable canonical form, and it will be always controllable. Okay, it will be always controllable. So next is this one, observable form. So same system we can write in observable also. So what we should remember? We should remember this method, and we will write the controllable form. Same thing will do the transpose. Okay. So transpose means controllable transpose will be the observable. Okay. So to write the matrix in the observable for same system, okay, this I have taken the transpose. So this is controllable form for same system, and this is the observable form. So if question will be asked, what will be the matrix for the observable form? So first we will write like this. Okay. Then we will just take the transpose of that matrix. That will be the matrix for the observable for the same system. Okay, is it clear? So this method we should remember. First we will write the matrix in the controllable form, then same matrix will do the transpose. So here A matrix I have done the transpose, so that row and column are exchanged. So 0 1 0 0 is the first row, and here 0 1 0 0 is the first column. So for the same question, this is also a state equation. This will also be valid, and it will give the same transfer function. Whatever the transfer function is here, that same equation it will give. But this is the observable form, and this is controllable form. Is it clear up to now? Hello, is it clear, or should I repeat once? Can anyone reply?
Clear, sir.
Okay, okay, okay. So we'll do some question based on this. Okay. So this is when matrix is given. So what is the transfer function? Here D is not given. Okay. So transfer function will be C into Si minus A inverse into B. Okay. So I'll tell how we can do without mistake. So first I will write the matrix C10 Si minus A inverse. So Si minus A will be S plus 4. Here it will be S plus 1. Here it will be 1. And here it will be minus 3. This inverse into Si minus A inverse B. This will be the transfer function. So how we can find the inverse of the 2 cross 2 matrix? Anyone knows the short trick? What is the short? This elements will be exchanged. Is it correct? So that I'm going to write. You can tell whether it is correct or not. 1 0. Okay. S plus 1, S plus 4, and here minus will be multiplied. I think minus 1 and 3. Okay. Is it correct? And in here determinant of this inverse means transpose of A divided by adjoint of A divided by determinant of A. A inverse is equal to adjoint of A divided by determinant of A. So adjoint means what we are doing, we are just interchanging this value and multiplying the minus in this one. So minus 1 and 3. Is it correct? Okay, I will write the. So what will be the determinant of this one? So determinant will be S plus 4 into s plus 1, correct, plus 3. Is it clear up to now?
Yes, sir.
Okay. So see, what people are doing, that is time consuming method. They are like multiplying. We should see we should don't divide this. Okay. What the students are doing, they will divide this. Don't divide this initially. First we do the top calculation. After that we divide with this one at last. Okay. So we'll see this 1 0 is there and this 1 0. So our matrix will be in top, it will be transfer function I am writing. So that will be first element will be s plus 1, okay, and second element will be minus 1, correct, and they should be multiplied with 1 1, okay, and in denominator it will be s square plus uh, 5s plus 4 plus 3 7, correct. So that will be s plus 1 minus 1. So our transfer function will be s plus 1 minus 1. So s divided by s square plus 5s plus 7. Is it correct? Is it clear? The explanation?
Yes, sir.
Okay.
Yes, sir.
Okay. 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 And moving to the next question. Okay. So see here how we can proceed for this kind of question. Okay. So a transfer function is given and we have to find the A, B, C, D matrix. Okay. So this will represent the y equation and this will represent the x equation. Okay. So always constant will be represented by x. So here this one I am assuming as x1. Okay. And this will represent the y. So y will be equal to 3x1 plus 2x2. x1 dot I am assuming as x2. So x1 dot is equal to x2. This is x1 dot. So what will be x2 dot? X2 dot. This will be x2 dot. So x2 dot will be equal to what will be minus 6 x1 minus 5 x2 plus q. So this will be our state equation. Okay. Always constant we will assume as x1. Okay. So this is I am assuming x1. x1 dot is equal to x2. So s is x1 dot. Okay. So x1 dot is equal to x2. Again this is x2 dot. So x2 dot will be, this will go in this side. So minus 6x1 minus 5x2 plus u. Okay. And is it clear up to now? So y will be, this is y, this represents y. So y will be equal to 3x1 plus 2x2. So constant is x1. So I'm going to write the equation x dot is equal to, is it clear up to now? x1 dot x2 dot is equal to ax. So a will be equal to 0 1 minus 6 minus 5 x1 x2 plus 0 1 u, and y will be equal to cx1 x2 3 2 x1 x2. Is it clear? Hello.
Yes, sir. But sir, is this a thumb rule or like this?
See,
Means,
this is the method we should use. Like, if we'll
yes,
write the
sir.
transfer function from this state equation, then we'll get this transfer function. Okay. If you'll apply CSI minus A inverse B, we'll get this one. So how to get reverse way from this transfer function to the matrix? Okay. So this approach we should apply. This represents for y equation. Okay. Constant will be x1 and this x1 dot will be x2. So y will be 3x1 plus 2x2. Okay.
Yes, sir.
This below equation will refer for this A matrix equation. So x1, this is x1, this is x1 dot. Okay, x1 dot is equal to x2. Okay, so x2 dot,
Means,
this is,
sir, x1 will come with constant, sir.
yes, yes. constant will be with x1. So this one
Yes.
is x1. So s represents for d by dx. What is s?
Yes. Yes.
So this is x1 dot. So x1 dot I am assuming as x2. So this s
Yes.
square will be x1 double dot
X2
means
dot.
x2 dot. So x2 dot will be minus 6x1. Okay, these two equation we are using separately. Okay, this
Yes,
top
sir.
and bottom we are using separately. So y is equal to 3x1 plus 2x2. Similarly, this below equation is there. So this is x2
Yes.
dot equal to minus 6x1 minus 5x2 plus u. So this is
Plus U.
second, because this side
Yes,
2 is
sir.
u is there. So these two equations we can write the ABCD matrix. Okay. So this,
Yes, sir.
if we'll do reverse thing, then we can get this transfer function. So this we should remember. This step should be remembered. Okay.
Yes, sir. Yes, sir.
Okay. So I'm moving to the next question. One second. Okay. So same thing. Like this is previous year gate question. Okay. So we should find the transfer this A matrix from this one. Okay. So what will be the A matrix? So see here, one x to the power 0 is there, s to the power 0 is there, s to the power 1 is there, s to the power 2 and s to the power 3 is there. So x1 dot I'm assuming as x2. Okay. x2 dot is equal to x3, correct? And x3 dot, this is x3 dot, this is x1 dot. Okay. x2 dot. So this is x3 dot. So x3 dot will be equal to minus x1, correct? Minus x1. Okay. And this will be plus 2x2, correct? And this will be minus 4x3. Is it correct? The x1 dot I'm assuming x2. Okay, this constant will come. Then x2 dot is equal to x3. This is x3 dot. So x3 dot will be equal to, because since that equation is not there, so that b will be there. hs is equal to ys by us. Okay, so that will come plus u. Okay, so minus x1, this will plus 2x2, and here it will be minus 4x3. Okay, so our matrix will be 0 1 0 0 0 1 and minus 1 2 minus 4. So A matrix will be this one. Is it clear? Minus 1 and 2 and minus 4. 1 1. This will be the correct answer. So is it controllable? Can anyone tell? Controllable or observable? This matrix if we are writing. So which form is this one? Already I have explained previously. So if this kind of 1 1 will come, this will be controllable form. Okay. Already I have explained
Yes.
earlier. So
Yes, sir. Canonical form.
canonical controllable form. If the transpose of this one will be there, like this will be there, then that will be observable form. Okay. So if question will be there like this, whether it will be controllable or observable, so it will be controllable, and this B is the correct option. Is it clear to all?
Yes, sir. For observable, sir, it should be transpose of this.
Okay. Observable will be like this: 0 1 0 0 0 1 minus 1 2 minus 4. That will be there.
Yes.
And here B matrix
Yes,
we are
sir.
getting, B will be equal to, B will be 0 0 1. Okay. So for observable, B will be equal to 1 0 0. Okay. And what is the C here? So C, if we'll see 3s minus 2, correct? So here this s square term is 3 term we require. So 2s x1, okay, minus 2x1 plus 3x2 plus 0x3. Okay, so for this system C will be minus 2, one second, minus 2 and this 3 and 0. This will be C for this controllable form, but observable it will become, C will become just transpose of this one. So that will be minus 2, 3 0.
3, 0. Yes,
So
sir.
this will be observable form. Is it clear?
Yes, sir.
Okay. Okay. Moving to the next question. Okay. So already that formula I have written. What is that? For that we should memorize that formula. So x of t is equal to phi of t into x0. Okay. Plus L inverse into L inverse phi s into b into us. Okay. So this phi of s is the state transition matrix in the Laplace form. So what is the x0? X0 is 0. So this term will be 0. Correct? So I'm going to write the phi of s value here. So phi of s will be si minus a inverse. Okay. So si minus a will be s1 0.5 s plus 1. Okay. The c value is not given here. 1 second. C is given or not? Okay, so C is not required because phi s b us only we need. Us is the step input. Okay, step input is required. So Si minus A, S here it will be minus 1, here it will be 0.5, and here it will be S plus 1. So Si minus A inverse, then B is there, so B 0, 1, and Us is a step. So this will be X of S. No, if you'll do inverse for this one, that will be x of t. So this is some transfer, some S domain function, which will, if you will take the inverse of that one, that will give the xt. Okay. So first we'll calculate this one. So the below will be the like determinant of this one. Okay. So s square plus s plus 0.5. Is it correct? S square plus s plus 0.5, and in top it will be s plus 1. So here it will come s, and here it will be s plus 1 and 1 minus 0.5. Okay, that will be the adjoint of that matrix. Then 0, 1. Okay, into 1 by s. Is it correct? So the first term will be s, and second term will be also, the first term will be s. Is it correct? So is it clear up to now?
Yes, sir.
So what will be the both the terms in this one? This is x. This will be a matrix. So if we'll write this one, so this multiplication if we'll do here to here, that will give 1. Correct? This s plus 1 and 1 is there. So if we'll do matrix multiplication with 0, 1,
1.
so that will be 1, and this bottom one will give
Yes, sir.
s. Okay. So that I am writing in the next
S
page.
plus 1.
So first one is 1, and here it is s into 1 by s. Correct?
Sir, second will be S plus 1. 1.
Second one will be, see, first multiplying a column, and
First
this
minus 0.
row and column.
Yes.
So row
Yes,
and
sir.
column will s plus 1 into 0 plus 1 into
Yes.
1. So
1.
that will be 1, first element. Then
And
second
this is
element will
yes.
be
Okay,
minus
sir. Okay.
0.5 into 0 plus s into 1.
Yes, sir. Yes, yes, sir.
Okay, so
This
that
is
will be
yes.
like this, 1 by s divided by s square plus, what is there, s plus
S
0.5.
plus 0.5.
S plus 0.5. So it will having the two elements. This is like first element will be like 1 divided by s into s square plus s plus 0.5. This will be the first element, and the second element will be 1 divided by that s will cancel, s square plus s plus 0.5. So these are the two elements. Okay. So x of t will be inverse of this one. So what it is asking? What is like 1 second, x2 of t. Okay. So x1 x2, x will be equal to 1 x1 x2. So that x1 x2, this is x1 first element, and this is x2. So x2 of t is inverse of this one. So x2 t will be L inverse 1 divided by s square plus s plus 0.5. So we'll see the option. Anything is there, like okay, and these things are there. So we'll try to put in this form. Okay, some exponential will come. So we'll see. E to the power 0.5, e to the power 0.5 is there. So everywhere 0.5 is there. So s plus 0.5 whole square if we'll do, okay, so what will happen? Okay, so it will be, I'm writing s plus 0.5 whole square. So this will give s square plus s plus 0.25, correct? And plus 0.25 we can add. So 0.25 here it will be there. So that will be, so 0.25 I can write as 0.5 whole square, correct? And here we can write the same thing, a by s square plus a square, that formula we can convert. So 0.5 into 1 by 0.5, correct? So this is a standard form, and that will be equal to e to the power minus 0.5 t, correct? Sine 0.5 t u of t, okay. And this 1 by 0.5 is there, it will become 2. Is it clear? So 2
Yes, sir.
e to the power minus 0.5 t, option which was there, I think this will be the correct option. 2 e to the power minus 0.5 t into sine 0.5 t. So just we have converted this into the standard form. Is it clear to all? Anyone have doubt? They can ask. Hello. Is it clear? Should I move to the next question?
Yes,
No
sir.
doubt, sir.
Okay. Okay. So x1t steady state value we have to calculate. X1t already we have calculated. X1 is 1 by s square plus s plus 0.5. So x1 s is equal to 1 by s square plus s plus 0.5, correct? So steady state value will be limit s tends to 0. If x1 infinity we have to calculate, so that we can apply the final value theorem. So limit s tends to 0, s into x1 s, correct? So that will be, ss will be cancelled. So that will be 1 by 0.5, that
Two,
will be
sir.
equal to 2.
Two.
Okay, it's easy only. So I'm moving to the next question. I think all of you know this. Okay. So this is the question. I think some error is there in this one. Still we'll solve. So how we can approach for this kind of question? Let's say 3 cross 3 matrix is given. Okay. 2 cross 2, easily we can find the determinant inverse of the matrix. But here also that same formula will be applicable. C into Si minus A inverse. Okay. Into B. Okay. C is given this one and B is this one. Okay. So C 001, 001. Okay. Si minus A inverse. So this is our A. Okay. And Si minus A will be, here it will come S minus 1, 0. Again 1, S plus 1, 0. And here it will be minus 1, 0, S. This inverse. Si minus A inverse B 010. Okay, and divided by determinant of this one, determinant of s minus 1 0 1 s plus 1 0 minus 1 0 s. Is it clear up to now? So how we can find that determinant of 3 cross 3, this inverse of 3 cross 3 matrix? Anyone knows the method? What is the method for finding determinant of 3 cross 3 matrix? or determinant inverse of the 3 cross 3 matrix. This one. Here we should put adjoint. Okay, this is not correct. Like adjoint here, this will be the adjoint of this matrix. So inverse it adjoint of A. This we should put adjoint in place of this matrix. Okay. To see what will happen, this will adjoint will be a 3 cross 3 matrix. Okay. So that 3 cross 3 matrix, if you multiply, so these two elements will be 0. One element will come -1. Here it will come something. Then here it will it will be 0 only, because since these two elements are 0, and for this one if you find the adjoint, then what will happen? Adjoint is this minus this. So how we can find the adjoint? This will be there. So then this cross multiplication, this into this. So adjoint for this element will be 0, correct? And what will be the adjoint for this element? S square plus s this minus this, s square plus s plus 1. Okay, for this will have some adjoint value. This one also will have 0 adjoint. Okay, so only last element will be there. So in that case I think this question is incorrect. Is it okay? I think because some adjoint should come here. Okay, see, this element will have some adjoint. This element will have some three. So let's say this, and this something is there. This one also. Let's say some three value come. But if we'll multiply this into this, so this top value, both value will become 0. If bottom will have some adjoint, that only will come into the picture. Okay. So if you'll see the adjoint of -1, so we'll do like this, and this cross multiplication will be 0. Correct? Similarly, for this 0 also, adjoint will be 0. So 0, if I am writing line like this, then this multiplication will be 0. Okay. So for 0 also, adjoint is 0. If S, and for this only adjoint is there. Okay. So if this adjoint is there, I'll multiply, this will be 0, this will be 0, and this will be some value. But if we'll multiply finally to this one, that will become 0. Is it clear? I think some data is incorrect in this one, or anyone getting something error is there in this explanation? Hello. The correct option is given as 1 second. B is given as correct option, but I'm thinking like the data is not correct. Anyone is
Sir,
getting? Ah, yes.
instead of inverse, why we are taking sir directly adjoint of
No. Like
A,
inverse is
SI minus A inverse?
so this only Si minus A inverse only I have done. So Si minus A adjoint of Si minus A divided by determinant of A.
Yes, sir.
Okay,
Yes, sir.
that thing I have done here. This is inverse.
Yes.
Okay. So here we should put adjoint. But see
Mm,
how I have analyzed. Adjoint means that will be a 3 cross 3 matrix. Adjoint of A will be a 3 cross 3 matrix. Correct?
mm,
That 3 cross 3 matrix, I am avoiding these values. This. Why I am not calculating these values? Because these two values are already 0. So if I will
yes.
cross multiply this, these two will be 0 only. Okay. So no need to
Yes.
calculate this one. Now we can focus on this one, these three values. Okay. So since bottom value is 1, if we'll multiply with this one, that will come as this kind of matrix, 1 cross 3. Okay, that 1 cross 3 will be multiplied with 0, 1, 0. Correct?
Yes.
So this element should be something positive, middle element. Okay. If this element anything will be there, that will come in result in 0 only. But if the middle element will be non-zero, then only something will come into the numerator. Is it clear? So I'm
Yes.
saying
Yes.
here, for this middle element, that adjoint should be some positive something, some value should be there. But if I'm calculating adjoint here, so how to calculate adjoint? Just cross this one and this multiplication, this minus this. So that is coming as 0. Okay. So it means that this some data is there. Here something should be there, I think. So if it will be 1, let's say it will be 1, if this value will be 1, like -1, and this will be 1, then something will be there. Okay, no, no, 1 will be there, then also this is 0 only, na? So here also something should be there. So it means some data value is there. So in this kind of question, how we can approach? Just find the adjoint of that particular value where we are getting the some values we are getting. Okay, remaining all calculation we should not do. So some one value will come and that value divided by the determinant of this matrix. Is it clear? Hello.
Yes, sir. Okay, sir.
Okay, okay. Move the next question. Let's see, already this kind of question I have explained, so I'm going too fast. So how we can approach ys by us is there. The top equation will represent the y, bottom will represent u. So x1 dot is equal to x2 I'm assuming. So x2 dot will be minus 6x1 minus 5x2, okay, plus u, okay, and y will be equal to 6x1 plus x2. So a will be equal to x1 dot x2 dot will be equal to 0 1 minus 6 minus 5, okay, x1 x2 plus 0 1 u, okay, and y will be 6 1 x1 x2. So this method what we are calculating, this is controllable form, okay. So what method I have explained, whatever we will calculate that will be the controllable canonical form. Is it clear? So which will be the correct option? 0 1 minus 6 minus 5, here we are getting, then it is 0 1 and this is 6 1. So B is the correct option. Is it clear? B is the correct option. Any doubt is there?
No doubt, sir. No
No,
doubt.
no, sir. No.
Okay, okay. So same question is there. It is asking the observable canonical state space form. So what will be the answer for this one? Just I am copying that here. So
C, option C will be there.
option C will be there. One second. I will just copy this one.
No, no, no. Uh,
One second.
minus 1 minus 5. Yes, sir. C.
Here we'll see. Now it will be more clear. So already we have the this is controllable. So that A will be just a transpose of this one. Okay. So for observable A will be equal to 0 1 minus 6 minus 5. Okay. B will be equal to 0 1 and C will be equal to 6 1. Correct. But here what it is showing, 0 1 is there, minus 6 minus 5 is there, 0 1 minus 6 minus 5. So I think okay, one second. Okay, I think option if we are seeing like which is the correct option? C is looking correct. I think C is the correct option. I have the answer. One second. 0 minus 6, 1 minus 5. 0 minus 6, 1 minus 5. But here something is okay. According to the formula, it should be like this. Okay, B should be 0 1. Okay, already I have explained written. One second, I will see one step. So this is the controllable. For observable, what we are doing, we are just taking the transpose. Okay, one second. Wait for 1 minute. Just see my notes. Okay, okay, okay. Some mistake I have done here. One second. I will just correct that. So B of OCF is equal to B of OCF is equal to transpose of C of controllable. Okay, this correction I am doing. C of, so B will be transpose of C and C will be transpose of B. Okay, so this will be B and this will be C. This I have done mistake here. So B of observable will be transpose of C of controllable. Okay. Similarly, C of observable will be transpose of B of controllable. So C will be here 0009. Here B is 0009. So C will be transpose of this one and B will be transpose of this one. Okay. So similarly, we'll do here also. 1 second. So here this will be B. B will be transpose of C here. Okay. So what is C? This is C. So B will be transpose of C and C will be transpose of B. Okay. So according to this is the correct option. Is it clear? Hello. So that,
Hello, sir.
yes, you can ask.
No doubt, sir. No doubt.
Okay, okay, okay. I'm moving to the next question. Just some questions are there. Okay. So e to the power 8 is something is there, phi of t. What is phi of t? That is inverse of this one. Okay, so just I am doing the fast calculation. Si minus a inverse. Okay, so Si minus phi s is equal to Si minus a whole inverse. Okay, so that will be s minus 1, s plus 2. No, here I have done mistake. That will be 2, and here it will be s plus 3. Okay, so that inverse will be s into s plus 3 plus 2, right? Here it will be s plus 3, 1 minus 2. Okay, so this is phi of s. So that will be s square plus 3s plus 2. So s divided by s square plus 3s plus 2. Here it will be 1 divided by s square plus 3s plus 2. Here it will be minus 2 divided by s square plus 3s plus 2. And here it will be s plus 3 divided by s square plus 3s plus 2. Okay. Can we factorize this one? Is it possible? So what is the method? How we can do? I'll just explain the method here. So just we'll factorize this one. We'll take the inverse Laplace. Okay. S square plus 3s plus 2. It will be, I think, s plus 1, s plus 2. Correct? Is it correct? So it will come to exponential term in t domain. It will also come as exponential term. It will also come as a exponential term. So sum at t is equal to what we have to do, e to the power at. At t is equal to 1, if we'll put the value, then we'll get some constant value x, y, z, w, and all we'll add, then we'll get find some value. It's easy only. Is it clear to all? Should I solve this or you can do it?
You can do, sir.
Should I solve?
No, sir.
Okay, okay, okay. So I'm moving some recent gate questions. So I'll do that one by one. So see that formula only, that is repeating formula. Already I have written that at first page only. So that formula I will write here also. Two formula we should remember. X of t is equal to phi t x0, okay, plus L inverse phi s into b into u of s. Okay, so this is 2 marks question. So phi t x0, okay. So x0 is given here 1 1. Okay, so what will be phi of t for this one? That will calculate. So phi of s will be phi of t, first I am calculating here. So that will be s minus 1, s minus 2, correct? 0 0 inverse of this one. Okay, so s plus s minus 2, s minus 1, and here it will be 0 0 divided by s minus 2, s minus 1. correct? So it will be here it will be 1 divided by, so 1 divided by s minus 1 and 1 divided by s minus 2. So e to the power t, e to the power 2t, correct? E to the power t, e to the power 2t, 0, 0, and x0 will be 1 comma 1 and 1. Is it clear? This first term. Hello. See, phi of t I have calculated. So phi of s is this one, this inverse. Okay. Phi of s is si minus a. Yes, you can ask. Hello.
Okay, sir, clear.
Okay. Okay. So this will be term, first term, and phi s we already know. So phi s is the si minus a inverse. So that is here it element inverse will be there. So phi s is 1 by s minus 1, 1 by s minus 2. Correct? Phi s b. So b will be there. X dot is equal to, 1 second. I think b is 0 maybe. Correct? So b is not given means this term will be 0. Correct? So we should take care of this only. So x of t, b is 0. B is not given means something will be 0, 0 will be there. X dot is equal to ax plus bu. Okay. If nothing is there in the B matrix, then we can assume that B is 0, 0. If B is 0, 0, this term will be 0. So x of t will be equal to e to the power t plus e to the power 2t. Correct? No, no. I'm doing mistake here. E to the power t and e to the power 2t, it will be in matrix. So e to the power t, e to the power 2t. Correct? So what is y of t? Y of t is equal to cx. Okay. So that this is C transpose into xt. So C transpose is 1 1. So y of t will be 1 1 into this one. So 1 1 into e to the power t, e to the power 2t. Okay. So that will be summation of these two terms. Y of t will be, 1 second. Y of t will be e to the power t plus e to the power 2t. At t is equal to 1, what will be the value? We can calculate. Second, I will use the calculator. Just 1 minute. So e to the power e plus e square. We have to do e plus e square. So e to the power 1 plus e to the power 2. How much we are getting? Is it correct or some mistake is there? Answer I have, I think. Okay, t, okay, 1 second. T value we have to put na e log e to the power 2 ln. So what will be that value? If we will put t is equal to, so that will, what it will be, first will be 2. First will be 2 and this second will be 2 square. Correct? See, log e to the power 2 if we will put here t. So e to the power ln something will be the that value. Okay. So it will be 6. Is it correct? See, we have to put t is equal to,
Yes, sir.
is it clear? Like total answer will be, this is numerical answer type question. So answer will be 6. Is it clear? Okay. So thus I will take this question. I think I have not seen this previously, but we'll solve this. 23 question. I think 23 paper was tough only, but we'll see it. I'm also solving it first time. So let's see. So ABCD is given. Okay. A, B, C, and D is given. And we have to find the value of omega for which steady state output of the system will be 0 and input is sine of omega t. So first we'll find the transfer function. Okay. So C, Si minus A inverse into B plus D. Okay. So C is at 3 minus 2. Okay. Si minus a inverse. So here it will be S minus 1, 1, S plus 2. Okay. This inverse into B, how much? 0, 1 plus D1. Okay. So I'm just, I think, doing here inverse only. So S plus 2 will come here. S will come here. Plus 1 minus 1 divided by S square plus 2S plus 1. Is it correct? Hello. The equation is correct. So here 3S plus 6 plus 2. So what will be the first term? See, here it will be a two term. This multiplied by this and this multiplied by this. But first term again will it will multiply with 0. Okay, so we should care for second term only. So that will be 3 minus 2s. So that is equal to 3 minus 2s divided by s square plus 2s plus 1 plus 1. Correct? Is it correct? See, this first is 3 minus 3 comma minus 2. This is minus 1 s plus 2 and here it is plus 1. Okay. So if we multiply this matrix first row and first column, so that will be some value. First row, second column, that will be also some value. But this value, if we multiply with this one, this two value will be there. Na? So first will be result in 0. So we should take care of this second only. Second will be 3 into 1, 3 minus 2s. So 3 minus 2s divided by s square plus 2s plus 1 plus 1. So again, further simplifying, s square plus 2s plus 1. In numerator, it will be s square plus 2s plus 1 plus 3 minus 2s. So s square plus it will be 2. Is it correct? Hello.
Yes, sir. Yes, sir.
Okay. So what will be this value here? So if we'll put j omega, okay. So s square here, so s square will be what? So s is equal to j omega minus j omega square plus 2, correct? Some mistake is there. S square plus 2s plus 1. See how it will be 0. At omega value, this magnitude should be 0. Okay. So magnitude will be under root omega s. But how magnitude will be 0? Is it clear up to now? So see, something I am missing. I think see transfer function is there, but at some particular value of omega, it will give 0. Okay. Is it clear up to now? This expression is correct up to now. So see, something is there, like input is sine. Okay, sine omega t. So what will be the output? Output will be at omega value, whatever the magnitude will be offered by this one, and into phase d. That you all of you know how steady state input we are for sinusoidal input we are doing. So the transfer function at what will be the magnitude contribution will, by this transfer function at that particular value of omega, that will be multiplied with the sine value. Is it correct? See, any transfer function is given, okay, h of s, some g of s is given, and we are giving sine input, sine omega t. So what will be the output? Output will be magnitude gs at omega into sine omega t minus phi. So what will be this phi value? Phi will be angle of this one at omega value. Okay. So this will be output. So how it will become 0?
Sir, transfer function is output by input.
Hmm.
So output will be equal to that function with Gs into input. Input is sine omega t. Then y minus phi, sir.
See, this some transfer function is there. So it will create some phase and magnitude. Okay, let's say 1 by 1 plus jx. Okay, 1 plus s. So s is equal to j omega. Okay.
Yes,
So
sir.
if any sine quantity we are applying to any this kind of network, what it will do, it will create a phase shift as well as it will multiply a magnitude. Okay. So
Oh,
magnitude will be 1 by under root 1 plus omega square and phase will be minus tan inverse omega by 1. Correct?
yes,
So,
sir.
so if sinusoidal input will be there and some g of s will be there, so for this kind of
Yes,
question, how we'll do? We'll multiply one magnitude with that sign, and again one sign will be shifted by the phi. So what is the phi? Phi is the phase angle of gs at value of omega. Okay, this type of question
yes.
already asked in the gate many times. So here also I think same thing they have asked. Maybe we are missing something. So, like, one second. So, what will be the here j omega if I am putting? Okay. So, anything we are doing mistake here, like something is missing. So, it will be minus 1. J square is equal to minus 1. So, minus omega square, correct? Omega will be equal to under root 2. Then only it will be, see, this j omega I am putting here, correct? Plus 2. S square plus 2s plus 1. So omega will be equal to under root 2. Is it clear? Or maybe if some mistake will be there, I think I have the answer, but answer is 2, I think. Maybe something mistake we are doing.
Sir,
So,
what we can do, we have got the transfer function. Just multiply with sine omega t means 1 by s square plus omega square, and then put the final value theorem, put s goes to 0. Then we will got to,
no, no, see, in sinusoidal kind of input, that initial and final value theorem will not work. Okay. That that sinusoidal input will be there, na? That is kind of a undamped system.
yes, sir.
So that's why here it will not work. Already this kind of question asked in previous year. So what is the step? See, this will come, magnitude will come with some omega square, minus omega square, plus some constant in top, and below
Yes,
something will
sir.
be there. So this magnitude will be 0 at some particular value of omega. Okay.
Yes, sir.
So that omega will be equal to under root k. Is it clear?
Yes, sir. Yes.
Okay. 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 So similar kind of questions are there. If any doubt is there, or should we solve some more question? Or any doubt is there till now? See, one more question is there. This one will solve. Should I solve this? This is also good question.
Sir, if in question it is asking for whether system is stable or not, so what
Okay.
we have to test? Controllability, observability, otherwise by other methods, sir.
No, no. Stability means we'll see the gain margin, phase margin.
Oh,
Okay. It's controllable and
okay.
observable is a different concept. That stability is the gain margin, phase margin, we can say.
Yes, sir.
Okay. So let's see. This is one question. The previous year gate only. So we'll see whether it is controllable or observable. So that method already I have explained here. It is written here. That rule B A B A square B we have to write. One second. So for controllability B A B A square B, this kind of matrix will write. For observable C C A C A square. Okay. So this I will do for this question. One second. So I am writing QC. QC is equal to B. So B is 1 1. Okay. Then B, then AB. Okay. So A into B will be, what will be that value? That will be minus 2, okay, and minus 1. Is it correct? QC is equal to 1 minus 2, 1 minus 1. See, B, AB, B, QC is equal to B, AB, A square, B. Okay. At 2 cross 2 is there, up to now only it will come. So, B, AB. So, AB is minus 2, minus 1. This is, if it will be equal to 0, then it will be not equal to 0, then it will be what? Controllable. Okay. So it is not equal to 0, then it will be controllable. Now I am writing CCA. Okay. So QO is equal to C. So C is 1, 0. Okay. And CA. C into A will be minus 2. Okay. And second term will be 0. So QO is equal to 0. So it will be not observable. Okay. So answer will be A. Controllable but not observable. Is it clear?
Yes, sir.
Okay. And this one similarly we can do like phi t yt is equal to like that one xt is equal to phi t x 0, okay, plus L inverse phi s b us, okay. But since here xt is 0, except t is 0, so this first term may be 0, and we'll do the L inverse of phi s b us, that will give a step response for the system. Should I solve this, or is it easy? Hello. Should we solve this one? Can anyone reply?
No, sir.
Okay, okay. So if any other doubt will be there related to control system, you can ask. Most of the question I have solved. If any other doubt is there, you can ask me. In last session and any kind of doubt related to control system, I will, if possible, I will be explained. Any doubt is there?
Sir, what is Jordan matrix, sir?
Jordan matrix. One second.
Yes.
One second. One second. Jordan matrix. I also. Okay, okay. I got it. Like this kind of canonical form, only some kind of matrix is there, na? That you are asking. Jordan form.
Yeah. Yes, sir. Yes.
Actually, I forgot that. Let me see in my notes. Is there or not? Like many forms are there. Like some standard forms are there. Like this. Already I have told no observable and a spatial canonical form. So that also will be a kind of form that we have to memorize. I forgot that matrix. Jordan form. Okay, one second. I have one example is there. I will try to write there. Okay, one second. So what will be the Jordan matrix? Like what kind of matrix will be there? So I will just write. I have one example. So that kind of form will come. Then we can refer that as Jordan matrix. So that example is minus 5, 1, 0, 0. Okay. Then second will be 0, minus 5, 1, 0. Again the third is 0, 0, minus 5, and 0. Again the fourth will be 0, 0, 0, and minus 10. Okay. So this is a matrix. This kind of matrix will be there in the Jordan form. Okay. So here this kind of line we can draw, and this in case of Jordan matrix, this all element represents the pole of the system. Okay. These are the poles. If this kind of matrix, Jordan matrix will like system static equation we can write in this form, then this represents the pole of the system, and B will be equal to 0, 0, 1, 1, and Y will be equal to some K1, K2, K3, K4. Something will be there. Okay. So more detail I don't have, but if this kind of Matrix
Sir,
will be there.
in assignment, sir, there was a question that Jordan matrix of 1 by S square is ABCD, then what is value of B and C?
Jordan matrix of 1 by
S square is
SS
given in matrix form A, B, C, D.
A
A,
B.
B, C, D.
Okay.
Then what is value of B and C?
YS by US is this one. That only, na?
Yes,
So
sir.
let's see what will be there. So y is equal to x1. Okay, normal matrix I'm writing. Y is equal to x1, and then x1 dot is equal to x2, and x2 dot is equal to u. Correct? If we write the matrix 0, 1, 0, 0, x1, x2, normal matrix if you write plus uh, that will be 0, 1, u. This is our x1 dot, x2 dot, normal equation, and y is equal to 1, 0, x1, x2. Correct? So if Jordan form, how we can calculate, we can convert this one. The pole of the system is 0 only. Correct? Na? So it is, I think it is in Jordan form only. Okay. I think it is in Jordan form only because this represents the pole of the system. Correct? This is representing pole of the system only 0 and 0.
Yes, sir.
I think whatever we have written this is in Jordan form only. So what they are asking?
Value of B and C, sir.
Value of B and C. So that will be 1, 0. I think I'm not 100% sure, but I think this only should be the answer.
Yes, sir. This should be answer. I think also, sir.
Hmm. Okay, I have some notes like that I will share next class. That Jordan, every matrix a standard form is there with more detail. And now I have my short notes that actual notes is not here. I'm in the lab now, so
Okay, okay, sir.
I will share those documents in that already documents I am uploading in that. So that will be helpful for your final exam. Okay,
Yeah, yes, sir. Thank you, sir.
okay. Any other doubt is there? Hello. If no doubt is there,
No, no, sir.
okay, okay. So thank you all.
Thank
So
you,
last
sir.
class I will like next Sunday is the last class. So that class I will summarize most of the thing. Okay.
Okay,
You
Okay,
okay,
can
sir.
come
sir.
with
Good night,
you
sir.
can come with your doubt also. Like that should be more interactive classes. So that will be more. Okay. Thank you all.
Good night,
Okay,
sir.
sir. Thank you, sir. Good night,
Thank you.
sir.
Good night.